Remote specialists can supervise imaging from anywhere. But this power hangs by a single thread, the network. When that network fails, the cost is staggering. Over $17,000 per minute in downtime. That financial cost exists because a patient's life is on the line. Reactions can turn lethal in 60 to 120 seconds. Your network's response time is not a simple metric. It's the countdown clock in a medical emergency. So, how do you architect a network for these demands? We'll detail the non-negotiable benchmarks for performance, compliance, and resilience. Before speed, there is law. The foundation of any remote supervision network is regulatory compliance. CMS mandates a physician be immediately available. This virtual presence doesn't mean an empty room. A licensed RN or RT must be physically present to handle the IV and contrast administration. With compliance met, we hit the most vital benchmark, response time. Top-tier networks connect staff to a radiologist in under 30 seconds. Why that specific number? It leaves the team a 30 to 90-second window to act before a severe reaction escalates. Every millisecond of lag matters. Beyond safety, network stability affects operations directly. Sites with poor virtual programs have much higher scan cancellation rates. So the network must be compliant, fast, and efficient. But what technical specs make that a reality? And what if the connection suddenly dies? First, the basics. A 10 megabits per second symmetrical speed minimum. Second, latency below 150 milliseconds, targeting sub 50 milliseconds for instant response. But raw speed is not enough on a shared network. Quality of service is mandatory, creating a fast lane for the supervision feed so it's never delayed. Finally, the physical connection matters. For this application, a stable, secure, wired connection is almost always superior to wireless options. Now, to answer our question, what happens if the main line fails? The answer is redundancy. A backup connection like cellular failover is a safety requirement. This resilience thinking must also apply to power. Backup power supplies for network hardware are needed for true continuous operation during a failure. So, we have a fast, resilient network. But how do we prove it is compliant? And how do we secure the patient data flowing through it? In an audit, if you cannot prove supervision happened, legally, it didn't. The network must generate time-stamped logs, creating an unbreakable chain of evidence. This documentation cannot exist in a vacuum. Direct integration with the hospital's PACS, RIS, and EHR systems is vital for giving the remote physician full context. Even with a perfect network, many facilities are slowed by old internal systems. Outdated PACS hardware struggles with modern images, causing new delays. And every packet of data must be shielded. HIPAA compliance requires end-to-end encryption, multi-factor authentication, and strict role-based access. Meeting these benchmarks is a challenge for large health systems. So, what advanced tools are organizations using to overcome these obstacles? For systems with many clinics, individual connections are inefficient. This is where software-defined wide area networks, or SDWAN, enter the picture. SDWAN provides intelligent traffic routing, choosing the best data path automatically. It also centralizes security and system-wide QoS enforcement. Technology is also optimizing staffing. KVM over IP allows one senior technologist to operate multiple scanners at different sites, maximizing scarce expertise. Looking forward, AI and cloud-based systems will further change this field. They promise to optimize workflow and make quality diagnostics more accessible. With all these pieces, from latency to SD-WAN, how do they combine to form a complete, resilient strategy for remote supervision? We call the $17,000 per minute cost of failure. That figure is the reason for this entire resilience strategy. Failovers and SDWAN are insurance policies. The CMS Immediately Available rule is about information, not just video. This makes PACS and EHR integration a compliance tool beyond its workflow function. Even with tech like KVM over IP, we still require a licensed professional on site. The goal is to support the on-site team with instant remote expertise. We've seen that a successful network is a living system of speed, resilience, and data flow. What is the final takeaway for building your own blueprints? The performance of a remote contrast network is not one single metric. It is a fusion of sub-50 millisecond latency, intelligent traffic shaping, and deep workflow integration. Your blueprint needs 3 pillars: uncompromising patient safety, driven by speed; ironclad compliance, proven with documentation; and operational efficiency. The future will be about extending this capability, bringing this level of care to underserved and rural areas. This makes network design a mission of health equity. Engineers, audit your QoS and redundancy now. Administrators, invest in the infrastructure that protects your patients. The network is the new standard of care.